In this video I want to show you how to derive the distribution of a sinusoid in a simple way. Let's consider the function x of t. So it's a signal and it is equal to the amplitude of a sinusoid times the cosine of omega t plus phi, where omega is the frequency of the sinusoid and the period of this signal here, this sinusoidal signal, is 2 pi over omega. Now, if we consider those values of t such that omega t plus phi is contained in the interval 0 pi, then we can take the inverse of this cosine here, because we know that the arc cosine gives values contained in this interval here, 0 pi. So we have to restrict ourselves to this condition where omega t plus phi is contained in this interval. So it means that if we consider x over a equal to the cosine, well, we can take the inverse and consider the arc cosine of x over a equal to omega t plus phi. The arc cosine, as I said, gives us value in this interval from 0 to pi. So we are restricting ourselves to this interval here for this variable here, omega t plus phi. So you can also find the restriction on t. That's simple from here, because t will be contained in the interval minus phi over omega and minus phi over omega plus pi over omega, like this. Because if you set t equal to minus phi over omega, you will get 0 for this variable, and if you set here t equal to this, it's easy to check that you will get pi. Anyway, now we can consider the following. So we can differentiate this equation, so we get dx equal to minus a sine of omega t plus phi times omega dt. We can write it like this, and then we can rewrite it also like this, dx divided by a, and then we divide by the sine of omega t plus phi. Can also be written as the square root of 1 minus cosine squared, because omega t plus phi is contained in the interval 0 pi, which means that the sign will be non-negative if its argument is in the interval 0 pi. So we can write the square root of 1 minus cosine squared. So I can write it as 1 minus the cosine squared can be written as x over a squared, and then this is equal to minus omega dt, like this. Now, when t is equal to minus phi over omega, x will be equal to capital A. It's easy to check from here, from this equation, because if t is equal to minus phi over omega, then this is equal to 0, the cosine will be equal to 1, and therefore x will be equal to a. Whereas if t is equal to minus phi over omega plus pi over omega, then you will get x equal to minus a. And therefore, for example, we can integrate both sides, so we can integrate from a to minus a, and then here we have dx over a, or if you want we can rewrite it like this, dx over the square root of a squared minus x squared. This is equal to minus omega, and here we have to integrate between minus phi over omega to pi over omega minus phi over omega dt. Now the integral here on the right, it's easy to check. It will give us minus omega times pi over omega, so it's minus pi. And similarly, also, we should get the same thing by integrating this integral here. So that integral can be calculated quite easily if we set x equal to, for example, a times the cosine of t. So if we make this substitution, we have integral from, instead of having a here, so when x is equal to a, the cosine of t should be equal to 1, which means that the cosine of t should be equal to, so t should be equal to 0. Whereas when x is equal to minus a, the cosine is equal to minus 1, so we integrate from 0 to pi, and then here dx is equal to minus a sine t dt, and here we have a squared minus a squared cosine squared, so we have a squared sine squared t, but in the interval between 0 and pi, the sign will be non-negative, so we get integral from 0 to pi of minus a sine t divided by a sine t dt, so this integral gives us minus pi, as expected, which means that if we consider this function here, 1 over the square root, so 1 over the square root of a squared minus x squared, and we multiply it by 1 over pi, so in this case we should transform this integral here. Instead of having from a to minus a, we should consider from minus a to a. So we are going to consider this function here, and when we integrate this function from minus a to a, so it's over the whole interval, this will be equal to 1. And this is none other than the probability density p of x. So the probability density p of x of a sinusoid is exactly this one, and it is defined only in the interval from minus a to a. Or if you want, you can define it from minus infinity to plus infinity, and it will be non-zero only in this interval from minus a to a, and it is equal to this expression here. So 1 over pi, 1 over square root of a squared minus x squared, just like this. And we found it from the signal itself, so the sinusoid itself. We managed to find the distribution from the signal, which is something that we did not do in this way in the previous videos because it was more complicated, but that theory was related to signal processing and it is more general than what we did here.